any record as well. So, like I said, we're looking at slope as a rate of change. So what that means is with our linear relationships, we're saying the line, definitely shouldn't have a wiggly line like that. Why it defaults to that. We're looking at a straight line that goes up, or we're looking for a straight line that goes down. Okay? So what we would say is, with this one, we have what's called a positive rate of change. And what do you think this one is? Negative. A negative rate of change. Now we've already done some discussion. How do I make a line go up quicker?
I forgot what it's called, but you could do like the squiggly line.
Oh no, I don't. I get exactly what you mean. That's just kind of using up the space. What I meant actually is, if I've got a line, how do I make it go up? I shouldn't have a. How would I make one without an end on it? Right. How do I make a line go up faster or slower? What can I say about? We did talk about this.
Space of coordinates?
No, we don't change the coordinates around. I'm not, sorry, maybe it's my language. I'm not changing this line, I'm having a different situation. If I remember, we said a line is straight if you can add the same amount on every time, yeah? What do I know about that if the line goes up steeper?
It gets bigger each time.
No, it gets bigger each time, but the number that I add on every time is bigger. If I add a bigger number, the line goes up quicker, right?
Yeah.
So if you charge your mobile phone, if you plug it in and it charges at 10% a minute, all right, it's going to charge at whatever, yeah? But if it charges at 8% a minute, is that faster or slower? And would the line representing it be steeper or less steep? Less steep. It doesn't go up as fast, right? So that's kind of what we're looking at. This rate of change is how fast something is changing. So the rate of change of how your phone is charged depends on how fast you're charged. What does change your phone charging rate? Anything, do you know, or is it always the same?
It's the piece that goes into the wall.
Yeah, so a better quality one of those.
Yeah, it's how many watts it is.
Yeah, exactly. So you can actually change the charging rate of your phone. You have to be careful not to buy a cheapy one that's fake from the market and it blows up on you and gets too hot. Yeah, I did buy one it got really, really hot and I realised before it burst into flames. So it is true. All right, so let's do one of these questions. Let's figure out what the rate of change is, and then that will determine how much the line goes up. So this is what we're looking at, the rate of change. So question 1. The average adult breathes in about 37 litres of air every 5 minutes. Okay? What is the rate of change of volume of the air? So this means that the line will go up. Okay? The line will go up. You don't need to draw this line every time. Right? But the amount of air that I have breathed, okay, will go up. How much? 37 litres. How long will it take? 5 minutes. Yeah? Okay. So my rate will be 37 litres in 5 minutes. But when we do a rate of change like this, we don't do it 5 minutes, we do it for 1 minute. Good. Alright, so what we do is we can say 37 divided by 5. You'll notice how it looks anyway. 37 litres divided by 5. Can you tell me what the answer is? Calculate. 7.4. So that is 7.4 litres per minute. And what that means is on my graph, if I were to go across 1 minute, how far would the line go up? 7.4 litres, yeah? And that is the rate of change that for 1 minute. So the answer to this question is 7.4 litres per minute. And we should write that as well. Litres per minute. Yeah, so that's what you're going to write down. That's the answer to this question. Okay.
How important is it that we draw like the line?
I would like you to draw this for this one. Alright. You can just do a freehand line, it's fine. It's better if you've got a ruler, I guess, but it is relatively important because the later questions you're actually trying to do this from the graph, not necessarily from the words. Yeah. So I'll tell you what, finish that and do question 2. So just to maybe add something, if you like to work this way, you can obviously look at the words, and the average rate is 37 litres, okay, so that's 37 on top, in, should we say, every 5 minutes, so that's the thing underneath. So for the second question, alright, you should have a teenager's heart pumps an average of 7,200 litres, right, every 24 hours. Okay. Did you all identify those? So that would mean, if I were to draw my line for this next question, right, what I've got so far is it would be going up how far? 7,200 every 24 hours. But what do you think we need it in? 1 hour. That'd be good because we've been. How do I know it's 1 hour? Why not 1 minute? Because they've given it you in hours, yeah. Right, litres and hours, they're the units. So, you don't need to make it harder than it needs to be. So we do 7,200 divided by 24.
Is 1,440.
1,440. 300, okay. Makes more sense. Exactly 300.
Yeah.
300 litres per hour. We must put our units in. Okay.
7,200 divided by
24. So I am going to draw this. So on the graph, what does that mean? Well, if I take a step across, which is 1 hour, we will go up 300, yeah? Now, this is where this word slope comes into play. What do you think slope is? It's how far the line goes up. It's how steep the line is. There's another word for slope I would like you to write down, which is, it's called gradient. Have you ever heard of the gradient of a hill? The higher the gradient, the steeper the hill.
I've heard the word, but I have no idea.
So both words are the same, like you go on a ski slope, yeah? But if we're driving around on the roads, a road has a certain gradient, you'll see it on signs and things, all right? So they go together. All right, so that means you can probably do 3 yourself. Okay. But let's have a look at question 4. All right. So this one, once we've done this, we're pretty much sorted. Yeah, but you can go back and do it. But I'm going to do this one with you, and then you can, like we've done before, you fill in the gaps afterwards. All right. So this one, look, we've got a graph this time. This graph shows the height above the ground of a rock climber over time. So first of all, Niall, what's the rock climber doing?
Climbing.
Is he
Climbing down.
climbing down? Okay, yeah. When you said climbing, you meant up, yeah. How do I know he's going down, Milo?
Because on the graph, the slope's going down.
Exactly. Look at the climber's height as time progresses. He is getting lower as time goes on, yeah?
So he's
And
falling.
because it's a straight line, we know he's going at a constant rate. Remember we talked about things are not necessarily that well representative of real life? Will a climber, actually, you tell me, will a climber go down at a steady rate?
Yeah.
Anyone do any climbing or anything? What happens when you come down?
You're stopping. If you're like rappelling down, then
Okay.
and then you're hitting the rock and you're jumping back.
Maybe, it depends. We're only going 25 meters, so it does depend. Like if he was actually climbing down, I think he'd probably be stopping. If he was just like you said, rappelling down, he might just slide down. Yeah. If you've ever been to a climbing wall place, you climb up and you're attached, and then you just jump off, and it lets you fall down, or someone lets you down. Or so actually, it could be a straight line, depending on how it's happening. Yeah. Yeah. So let's calculate the slope of the graph. So what we need to do is first off, we take information that we know is true, not what we think is true. So what I know is true is that this is 0, 26, and this is 8, 0. So do you remember with what we did before, we were looking at how far up or down, and then doing it with how far across, yeah? So how far down has the climber gone? No, 26 meters, isn't it? He's actually come down, not minutes.
It's a little bit above.
Well, it's not even that, look at the numbers.
Oh yeah.
Yeah, the number says 26, it's slightly above, but that's when I take the information I know. And we go from 26 down to 0, okay? And then how long did that take? So from 0 time up to 8. It took 8 seconds. He was coming down fast. So he probably was on a road. Yeah. So the slope of the line is 26 divided by 8. Okay. What did you get?
3.25.
So what I would do here, we can treat this as a fraction with a slope. So if I divide by 2, are you okay that that would be 13 in 4 seconds?
Do you have to divide or?
I would say as a slope of a graph, right, you're asked for the slope, it's best to leave it as what we call, I'm going to introduce you something you're going to hear over and over again, okay? We're going to have rise over run. Now we're actually doing something, we've missed something here, because what did I say at the very top about a line that goes in this direction? It's a negative. So our rise is actually a negative. We've done negative. So we've gone down is negative 26 meters, right? So our slope is rise divided by run. Do you understand the rise and run bit?
Rise.
So rise is up and down. Run as in you run straight along, yeah? So this is the run, and then the rise can be up or down. If it's down, it's negative. If it's up, it's... And it's quite nice with just saying the slope of a line to leave it as a simplified fraction. But when it says interpret the slope as a rate of change, we're then going to do what Sienna's already done, which is to do negative 13 divided by 4, or negative 26 divided by 8, you should get the same answer as, what was it? 3.25,
Negative.
so it's negative 3.25 meters per second. Yeah? Alright. Easy enough?
Yeah.
One note here though is, like I did, take the info given. Right? Don't try and assume anything. Don't try and read from the graph if you've been given coordinates. Alright? Does that make sense? Okay. So I think probably you can do the same thing here, look. You definitely can't read off the graph, but you can use the coordinates. So I'll leave that one back on the board, but have a go at question 5. No, but you don't need to. So, like I said here, again, if you like to sort of use your colours to specify things, look. So temperature is the thing that's going up or down, yeah? So that's those numbers, all right? Where do those numbers appear in the coordinates? Right, that's the 25, look, and the 13. So those numbers are the rise, yeah? So this is the rise, but the rise is actually a fall, so we have a negative rise. And then this is the run. Run is always positive, okay? And we look at that, and like I say, we want to highlight or something. So this is the run, and those numbers match with these numbers. So it's really important that you get them the right way round. This is a common mistake where people get them upside down. So if you were to do what's the slope of the graph, well, you're going from, so we do the rise has to be divided by the run. So we go from 25 down to 13. So what would it be? From 25 down to 13. What's the difference between the two?
12.
12. So my rise is actually negative 12 divided by, well, the run is going from 200 to 2,200. What are you confused with?
No, it's just now when I over here, it was this one and that one.
No, it wasn't. No. 25 down to 0. 25 down to 0. And this one is 0. The problem is there's 2 zeros, I guess.
And now it's like 2,000.
Yeah, well, the numbers are just bigger, but they're the same. Yeah, it's the same maths. So the run, look, if you look at it, we're going from 200, which is about 200 there, yeah? So we go from 200 up to 2,200. So what is that run? How far?
2,000.
What's the difference? So 2,200 minus.
2,000.
So maybe we should do that actually. That's something a lot of people do. So the rise is the difference from, so it's 25 minus the 13, and you get the answer 12. But because it's going down, we know it's negative, yeah? The run then is the from 200 to 2,000, so 2,200 minus the 200, and the difference there from 200 to 2,200 is 2,000, yeah? So we are going down 12 degrees every 2,000 meters. Does that make sense with water? Any divers amongst you?
Is that the final answer? I'm kind of confused.
Not yet, it's not the final answer yet. What's up?
Why do you have to include both numbers?
Right. Do you understand this one?
Yeah.
Well, what's different then? So, for instance, with this one, look, if I highlight it, the rise, oh, wrong colour. The rise is from 25 down to 0, yeah? So 25, or 26, sorry, down to 0, yeah?
Yeah.
So that's the rise. So from 26
Okay.
down to 0 is minus 26. Alright? Then the run here, we go from 0, there's no 0, there's like you were saying, Alistair, just put the 0 in the corner for both of them. But we go from the 0 to the 8.
And that would be the one.
And that's the 8. Yeah, that's the run. Where does the negative 13 over 4 come from?
When you divide it between the two.
Yeah, so we just simplified, yeah?
Okay.
So, do you then see how that matches to this one? Same thing, yeah?
Yeah.
So we know the line goes from here down to this point. So where was it? It was at 25 and it drops down to 13. How far did we drop? 12. Yeah? Got that? How many meters did it take to drop 12 degrees? Well, we were at 200. We then went to 2,200. Sorry, this is going up, not diving, isn't it? So it's up in the air as you go up in your plane. How far up did we go?
In 2000.
Well, we went from 200 up to 2,200. So how far did we actually go up? 2,000, yeah?
I'm confused. How is it good now?
Right, I am, like, because of the, what does altitude mean?
How high?
How high you are.
How high you are. So this is telling me, as I go higher, the temperature comes down. So, I mean, we get it, right? This line, so imagine, what would you be in if as you go up, it gets colder? Give me some examples. You could be in a plane, a balloon, you could just be in a car going up a mountain, be in a helicopter, yeah? So what this is telling me is as I go up, the temperature comes down. What it's not doing, the line is not telling me I'm going down. Right, I have to be able to, you saying, are you with me? You were asking this, stay with me. Right, so this is telling me as the altitude goes up, the temperature comes down. All right, it's not saying now this is, I get it, right, I'm starting to twig where the problem was. Because in this problem, look, as time goes up, the climber comes down. And the line is down and the climber's coming down. Yeah? So it looks like the climber is this person, this doing this, yeah? But it's not really that, it's the time and the heights that we're actually measuring. Okay? Yes, Liam?
Does that explain why it's so hot in countries that are, sorry, can you explain why it's so cold in countries that are very north, and so hot in countries that are very south?
That's more to do with the tilt of the planet. So as you know the planet is tilted like this, yeah? So this is like the North Pole and this is the South Pole. So you can probably do this in science. If this is the sun over here, all right? If this is like Australia here, and this is,
Canada.
let's say Canada, right? When the planet's like this, it will be rotating, right? Canada will be in its summer, and Australia will be in its winter, because it's further away from the sun. Now what happens as we go around the sun, when we're on this side of the sun, the planet is then still tilted, but Australia is now closer than Canada, so Australia will be in summer, and you know, so that's not this. This is more about height. So, for instance, does anyone know about Bolivia, for instance?
Yeah.
Yeah, Bolivia is really, really high. As you get higher, the temperature can be colder, right? But it depends where the Earth is as well compared to the sun. It has also an impact. But it's also like, why don't we have really cold winters?
Well, because we're in the, it has nothing to do with the equator, because we're in like the Gulf of Mexico.
So it's got lots of things to do with lots of things. So we are nearer the equator, so our temperatures doesn't change as much as maybe, say, Iceland or something, right?
To be honest, if we weren't in the Gulf of Mexico, we'd probably get snow.
Yeah, but also we're surrounded by water, we're surrounded by warm water, there's lots of things that combine. But if Bermuda had a massive big mountain in the middle of it and we could go 4,000 meters up, we would get cold. Yeah? So when I lived in Switzerland in the summer or in the spring, it was good. I was in Switzerland and I was about at probably 600 meters where I lived, but I could go skiing at about 2,600 meters, very close to where I lived. So I would go up, yeah? Now when I was up, wrapped up on the snow, yeah? When I came down in the afternoon, I'd be shorts and t-shirt and swimming in the lake, having barbecue and stuff. I could do both at certain times in Switzerland. When it got to the winter, it was cold everywhere, but it was still colder up. Yeah? In the summer, it was roasting hot down by the lake, and I could go up to the mountain. It was still hot, but it was cooler up there. So that's what this is saying. As I get higher, the temperature is going to come down. But I can understand where the issue. Let's just finish this question though. So temperature is coming down 12 degrees every 2,000 meters. Right? What's the rate of change? So we've done it as a slope. Is there any simplifying? Could we say it's negative 6 over 1,000? Are you happy with that? Good, yeah, negative 3 over 500, yeah. Stop there? Okay, what about rate of change then? So now you would do negative 3 divided by 500 and you would get the answer 0.006 degrees Celsius per meter. Negative, yeah.
Why is it negative if it's going up?
It's not going up.
But you said.
What am I measuring? I'm going up, but the temperature is coming down. So when we're talking about rate, we're talking about how does this y value change, yeah?
Yeah.
How is that? Because that's the one. What if I was somewhere where it got colder faster? What would the line look like?
It'll be a lot steeper.
Steeper as in it would come down quicker like that, yeah?
Yeah.
So it's the temperature that comes down quicker, not me going up quicker. Does that make sense to you? Yeah? So this rate of change is about how the temperature is changing. It wouldn't make sense to do it the other way, would it? If I said, oh, I want to be up there, oh, all you have to do is change the temperature. That doesn't make sense, does it? Right? I want to be in an aeroplane. Oh, okay, I'll just set the air conditioning to 70 instead. That doesn't make sense. But if I said, I want to be colder, you could say, oh, well, you have to go and walk up the mountain then. Does that make sense? And that's what this is suggesting. If I was in a place that I could walk up, not as far, but get colder, that's what a steeper line would do. Make sense? Okay, cool. Right. I'll do a Zoom meeting, do I?